Hello, everyone. Thank you for joining. I'll just hang on a bit longer and see if we get a few more attendees on. We're a little bit early still at the minute, so give it another minute or so. Okay, well, it seems to be bang on time, so let's get started. Hello, everyone, and welcome. Thank you for joining us today for the webinar on adhesive applications. I'm Louise Scott, Global Marketing Manager for IPS Adhesives, and I'll be the moderator today. So we're here to explore adhesive part joining, something that's impacting part assemblers in many industries, and we've gathered insights to help guide you through various solutions. Joining us is Taylor Santa, who's Technical Support Specialist at IPS Adhesives. She's a skilled practitioner of chemistry and has worked with adhesives for many years. At IPS, she's handling daily inquiries relating to adhesives and substrates. So here's how the session will run today. We'll start with a presentation from Taylor, take about 25 minutes, and finish with questions and answers. There's a Q&A box at the top. So as we go through the presentation, feel free to put your questions in there, and obviously we'll tackle those at the end. Just to let you know that the session is being recorded, and we'll share it with you attendees afterwards. So I'll let Taylor take over now and start the presentation.
Hello, everyone. Thank you for joining today. We're going to talk a little bit about part joining within different industries, but a little background. My name is Taylor Santa. I am a technical support specialist for IPS and SCIGRIP Adhesives. I have a degree in chemical forensic science from Western Carolina University, and I've worked in the adhesive world for about 8 years. Within that time, I worked in several different departments, whether it was quality control, performance testing, research and development, and now technical service and customer support. IPS Adhesives, a little bit about us. We are a division of IPS Corporation. We are a manufacturer of methyl methacrylate adhesives, supplying several different markets, from home building remodeling to marine transportation, rail, and others. The SCIGRIP brand has adhesive offerings that bond together metals, plastics, and composites, as well as cross-bonding between all three. We have 2 locations in Durham, North Carolina, and Newcastle in the UK, both of which are 9001 ISO certified, and we are able to provide adhesive across the globe from these 2 locations. All right, so when we are designing parts, you're going to be joining things in several different configurations. There are several different types of ways that these parts are going to be joined. These are the 4 most common that we see. Down at the bottom right, you can see the tongue and groove. It's a piece where there's a piece cut out, another piece slides in. In the middle at the bottom, there is a T-joint, which is a perpendicular joint. On the bottom left is a butt joint, which is the pieces are coming up right next to each other. And then the most common that we see is a lap joint. These joints are overlapping joints with adhesive, rivets, bonds, something like that in the middle. With all of these different types of joints, we also see many different types of stress. These relate to different types of push, pull effects on the end-use part. For example, if you're attaching a cosmetic panel on a vertical wall inside of an RV, you are going to have a piece where nothing is moving, and then a piece where gravity is actually working to pull down and create shear stress. With one side of the panel holding still, tensile, on the other hand, is force being applied in opposite directions away from the bond zone, like pulling an Oreo apart, basically. Compressive stress is also force being applied in the opposite direction, but being pushed towards each other instead of pulling the pieces apart. The last two common types of stress are peel and cleavage, which you can see on the right-hand side here. These types of stress relate to pulling in uneven ways. In peel stress, you're going to have one piece which is held still, and then another piece which is having the edge lifted away from the part that is being held still. Cleavage, which is a type of peel, is where the same edge of two substrates are being pulled apart at the same angle. I kind of like to think of this one almost like opening a Band-Aid, or so you're pulling apart those two. There's a piece at the bottom that stays still, and that's kind of demonstrating cleavage stress. The types of stress on a fixture line must be taken into consideration when designing large and small part assemblies. These stresses can all be tested using universal testers, and many adhesive manufacturers have these testers following specific ASTM methods associated with the stress. With these types of stress we were talking about, we see different types of failures. When testing parts for joining, some of these failure modes are better seen from an adhesive perspective than others. We're just going to go straight down the line in terms of these photos. The main failures that we see in the adhesive world, at least, are adhesive failure, cohesive failure, and substrate failure. When using adhesives, the worst failure mode you can really have is adhesive failures, which is demonstrated on the top photo. These adhesive failures are shown when you have clean separation between the adhesive and the substrates. This mode indicates that the adhesive was unable to actually adhere or grab onto the substrate itself. The next two types of failure modes are kind of more what we want to see in the long run. First, we have cohesive failure, which is the middle. This is where the separation is running within the adhesive. The bond within the adhesive actually fails itself. This type of failure ensures that there is a proper adhesion to the substrates. And you can see in that photo that there is the orange adhesive on both sides of the substrate when it breaks. The final failure mode at the bottom is substrate failure. This mode is characterized by the substrate itself failing by either having a clean break away from the adhesive bond or fibers breaking away from the greater substrate. You can kind of see that demonstrated in this photo at the bottom. You have the orange adhesive and then the black layer of fiber tearing away from the substrate itself. This substrate failure is actually showing that the adhesive bond is greater strength than the actual substrate itself. Welding, riveting, and mechanical fastening are other ways that people are joining, and it's historically been the most common within almost every industry. Even with this, there are some challenges of using these joining methods. Welding, for example, requires very highly trained employees to create well-done welds. Due to this high level of skill, it can be very expensive and very difficult to hire the correct people to create great joining. Riveting and mechanical fastening can be done by an average employee, but these joining types have problems of their own. For example, bolts, screws, and rivets, by just the nature of how they work, damage the substrate itself. The placement of the hardware creates a weak point in the substrate, and it is more likely to wear down that point with vibrations and long use of the parts. The stress gets focused where the bolt and rivets are, creating a weaker overall bond. The bolts and screws could also become loose with high vibrations and could fall apart quicker than expected. When using adhesives, you'll actually have a more widely dispersed stress area, and that will lead to a longer bond life and just stronger bonds in general. Another often not thought about challenge with riveting and mechanical fastening is if you are putting in a rivet every 2 inches down a line, the weight of those rivets are going to add up, and it's going to lead to a heavier piece overall. So if you're trying to, like most of the industry is trying to lightweight your pieces, you're actually going to you could actually take out a lot of weight by removing these rivets and bolts and adding adhesive. So adhesives, like we were talking about, are a very good way of joining different substrates and different parts. Some benefits for these adhesives and part joining is they're very easy to use. put a mix tip on a cartridge, purge out some sample, and you're ready to go. So it's very easy to get any of your employees to be using the adhesives as opposed to having highly trained individuals for welding, or having to take time to show every employee who's going to use this how to do a little bit more difficult things such as riveting and bolting. Like we were talking about, adhesives are much more lightweight than the massive metal that you're going to be putting in. And if you're welding, a lot of times you have to do the same substrates. You have to have metal to metal. With adhesives, you can bond your acrylic piece onto a metal piece and not have to worry about the welding. You can't weld metal to plastic. Adhesives are also very easy to set up and prep, and the curing time is very quick, so you can get through your process very, very quick. Overall, adhesives are more aesthetically appealing. You don't have the screw heads or the bolts or the rivets. You can pretty much eliminate those. There's very little finishing work, and that when you're welding, there's a chance that you can have more post work if the weld is not 100% perfect. And then with adhesives, you're not using a hot torch, or you're not having these big machines to help get into it. It actually reduces the risk of injury. But there are some limitations to adhesives. MMAs, which is what SCIGRIP produces, they do have a bit of a smell to them. I do hear a lot, oh, it smells different. But if you're using it in a well-ventilated area, it is not dangerous. There are thousands of people using MMAs daily. They can be a little bit messy if you're not done correctly, and you do need some special dispensers if you're using a cartridge or a big bulk machine. So we'll just talk a little bit about different types of adhesives in general. I'm sure everyone has heard of polyurethanes and epoxies. MMAs tend to be a little bit newer of a technology that people really haven't seen. So there are three main types of adhesives, like I talked about: epoxies, MMAs, methyl methacrylates, and polyurethanes. There's a few differences between all of them, but the main differences we're going to really talk about today is strength and elongation or flexibility of the cured material. So first we'll talk about epoxies. When you are using an epoxy adhesive, you're going to see very high strengths. Because of the strength is so high, though, you will find that it is much more rigid. This rigidity is more displayed as being more brittle, basically meaning that this has a low resistance to vibration. Next, we'll talk about polyurethane, which is kind of on the other side of it. It is a very flexible adhesive, much more resistant to vibrations and impacts. But because of this large elongation and flexibility, we tend to see lower amounts of force needed to actually pull the pieces apart. And then finally, we come to MMAs, which kind of bridge the gap between epoxies and polyurethanes. They have high strengths, lower than epoxies, but they also have fairly high elongation and flexibility, not as high as polyurethane, but you're still getting the strength and the flexibility in one product. With this type of adhesive, we see strengths that are high enough for most bonding, as well as high enough elongation to withstand a lifetime of high vibration pieces. Due to the high strength and high elongation, MMAs are the ideal adhesives for part joining across several different industries. So you have these parts and you want to use an adhesive to bring them all together. There are a few things you really need to keep in mind when you're choosing an actual adhesive. So the number one thing is your time restraints. How much time do you have before these parts? How much time is it going to take for these parts to get put together after the adhesive is laid? So you need to know how much working time you have for the adhesive, and then how long do you have before the parts actually need to be moved? So what is your fixture cure time? Some other things are what type of application are you going to applicators are you going to have? Are you going to be using a ton of adhesive? Do you need a big bulk machine? Do you need just cartridges and manual dispensers? What is the strength and flexibility you need? Is this a high vibration piece? Is this a little bit more rigid? What type of color do you actually need? do you need to be able to sand and paint this adhesive after it's cured? And then do you have any environmental considerations such as UV, salt or chemical exposure, service temperatures after cured, stuff like that. And the last thing to take into consideration is the environmental temperature where you are using these adhesives are actually going to impact how much working time you have. So if you're working in an unconditioned plant in Florida in August, it is very hot. Because it is so warm, the amount of time you have before the material starts to cure is going to be drastically diminished. So if you need to have enough working time in your environmental temperatures where you're using this product. So you have your adhesive, you have a sample. What do you do now? You're going to take your parts that you want to be tested. You're going to clean the area. In order for these adhesives to really have the best possible outcome, you want to have a clean, dry surface that is free of dust and oils, and that even includes oils from your hands. You're going to prepare your cartridge, which I'll show a video here in a second, just talking about how to purge a cartridge. You're going to want to lay a bead of the adhesive in the bond area, place your pieces together, and then I always like to put weights on the pieces that I'm putting together because you never know who's going to come up and bump something. So just so nothing is going to be moved while the curing is happening. When you are prepping a cartridge, you really do need to make sure you are purging your cartridge properly so you're getting a good mix ratio. At the bottom here in that picture, you can see at the very beginning of that bead, the colors all over the place. If you know that this is going to be a black product, you can actually use the color to help you figure out if your mix ratio is better. So yeah, towards the end, it's a more consistent and more defined color across the board. So just kind of using that can help you just visually identify if it's going to work. And I'll just going to show a video here for a second, just demonstrating how to basically start a cartridge and purge a cartridge. And we do have this video on YouTube and some other places if you do need to reference back to it. All right, so you have these parts, you bonded them together, you let them sit for the fixture time. What now? You're going to take something where you can grab onto. A lot of people just use their hands, but apply force in the same direction that you're going to see at the end use part. So if you're going to see something that's going to be bending a lot, you can bend it with your hands, but if you're not going to see that, that's not going to be a good indicator of how the adhesive is going to work in your part. Here on the right, you can see someone just taking a wrench and just pulling on that piece after it had been bonded. In this case, the piece actually bent before any of the adhesive lifted up. I don't think it did at all. In that vein, though, if you would like to see numerical force data on your substrates, please reach out to us, to our technical team. We have a full application lab, and we are more than happy to test your parts in our lab in Newcastle and in Durham. All right, so now we're just going to kind of go through a couple of part joining adhesives that are being used across several different industries from the SCIGRIP brand. So the first one we're going to talk about is the SCIGRIP 100 series. This is a 10-to-1 two-part white adhesive. It's an MMA adhesive. This product was designed to be on very visible areas. So it is bright white, it is UV resistance, and it is designed to take a beating from the sun. We see it a lot in the marine industry with tank doors and hardware being put on. You have a choice of 15 or 40-minute working times. It is a non-SAD product even when vertical, and it has excellent fatigue, impact, and shock resistance. And it comes in a 490 ml cartridge and then bulk. The next product is the SG300 series. This is our workhorse of our adhesive lines. This product, again, 10-to-1 MMA adhesive, multiple working times, a few different colors. But this material is designed to have very little prep of your substrates of, you can bond metals, composites, plastics, you can cross bond. This series is designed to do almost everything in a building with one product. It was designed to meet specific requirements of transportation industry. It exotherms, or it heats up to such a low temperature that you're not going to see any read through or print through on thin composite surfaces or metal surfaces. And that helps eliminate post work. It is also non-sag and also comes in cartridges as well as bulk. Next, we have the SG5000 series. This is a 1-to-1 product, and it is designed as another all-over product. We see it used a lot in carbon fiber to steel clipping and racing seats that you see up here. A lot of aftermarket auto bonding, as well as actually fiberglass mold repairs. It comes in a 6 and 13-minute working time in the US. It's made from metal, plastics, and composites. It's got a flowable viscosity, so it can be used, it is injectable. It's high tensile and shear strengths, and also cartridges and bulk. Lastly, we have the SG400 LSE. LSE stands for low surface energy plastics. We all know that that low surface energy plastics are almost impossible to bond. We designed this product to have very minimal prep with the LSE plastics in order to bond, and it can actually cross bond between the LSE and aluminum, FRPs, anything like that. It's, again, a 2-component 10-to-1, bonds well to polypropylene, polyethylene, things of that nature. And we've seen it used in roto-mold repair. If there's pinholes, this can actually help seal up those pinholes, reducing scrap and post-finishing work. And this one does only come in 2 cartridges. So just kind of overall, welding mechanical fastening has its challenges. It's heavy, you need specialized personnel, and the likelihood of the loosening and breaking of these mechanical fasteners is very high. Adhesives, on the other hand, are an easy way to assemble large and small parts. There's a permanent bond, a lightweight bond, and they're easy to use for anyone across all industries. And that's all I got for you today.
Hey, thank you, Taylor. I'm looking now to see if anybody's got anything in the question and answer box there at the top. The moment there's nothing there, but if you'd like to ask a question of Taylor, take time to put something in there now, and we'll hang on and see if something goes in there. Nothing in yet. Give them a little bit longer just in case somebody's there and wanting to ask a question. In the meantime, I will say for now, this kind of concludes the webinar. And I would like to say thank you to Taylor for the insights that you've shared today. I'm sure you'll all agree that it's been valuable. It's been a valuable session. Obviously, thanks to all of you for joining. We really appreciate your time and your participation. If we get any participation. We will send out the recording. We will send any relevant resources. And if you'd like to continue the conversation and ask questions and things that you haven't thought about at this moment in time, you can reach out via the SCIGRIP website on the Contact Us page, and be sure to follow us on LinkedIn, of course. And also look at the resources page on the SCIGRIP website. There you'll find more content like this. There's no questions yet in the question and answer, so we'll leave it for now. And just to say thanks again, and we hope to see you next time, and take care. Bye-bye.